Okay, so we've stumbled upon something pretty wild that's been making the rounds online. It's called the Jetstreamin Canon. Now, what is it? That's the million-dollar question, and it's exactly what we're here to figure out. Let's start digging in. And right out of the gate, it hits you with this line. No hello, no welcome, just, this is the authoritative unified set. It's so bold, so direct. It immediately sets this tone that, this isn't just some friendly suggestion. It's a declaration. And of course, that leads you to ask, the authoritative set of what? Is this a new protocol? Some kind of manifesto? A mathematical proof? So that's our job today. We're going to be like digital archaeologists, decoding this thing piece by piece to see what's really going on under the hood. All right, first things first, let's dig into the foundation, the basic architecture of this thing. You got to understand the blueprints before you can understand the building, right? Okay, so Canon 1, the very first rule, lays down the law. It establishes this unbreakable chain of history. Basically, the identity of any new piece of information is mathematically locked to the piece that came right before it. What that means is you can't go back and change the past without completely shattering the present. This whole system is built on a perfect, verifiable memory. And this is a really big deal, because we're not just talking about a simple log file here. A hash function like SHA-3512 creates a totally unique digital fingerprint. And by baking the old fingerprint into the new one, you're creating this sealed, nested chain. It's designed for creating absolute trust in the system's own history. So an unbreakable history, that's a powerful concept, right? But it begs the question. A chain of data needs to exist somewhere. It needs some kind of container, some boundaries. So where is all this happening? What's the shape of this universe? And this is where it gets kinda weird and cool. Canon 3 gives us a major clue. It defines a very specific 3D shape, a cone, built from a logarithmic curve. Now, this cone shape isn't just decoration. It pops up again and again in this document. It seems to be the fundamental boundary, the literal container for the whole system. And then, boom, Canon 21 tells us why this cone is so important. It's basically a guide rail. The system, which it calls the model, is constantly being measured against the perfect shape of this cone. If it strays too far, if this alignment arrow gets too big, it's considered a failure. So the cone is there to enforce discipline, to keep everything in line. Okay, so let's recap. We've got this perfect history locked inside a guiding cone. But this thing isn't just a statue, right? It's not static. The document makes it super clear that the system is alive, it's dynamic. So let's take a look at how it actually learns and evolves, how it breathes. Canon 7 is really the key here. It introduces a formula for something called stochastic evolution. Now, that's a fancy term, but it just means the system is designed to evolve with a big dose of randomness. Imagine a little particle. It's being pushed by a steady wind. That's the predictable part. But it's also being hit from all sides by tiny, random jolts. That's this system. It's designed to be in constant, somewhat chaotic motion. So where does all this random chaos come from? Well, check this out. The system is juggling two different kinds of entropy, or randomness. On one side, you have its own internal uncertainty, which it's always trying to shrink as it learns more. But, and this is the wild part, on the other side, it's deliberately pulling in new randomness from a physical noise device. It's literally importing chaos from the real world. You might be thinking, why on earth would a system want more chaos? And that's a great question. Canon 22 gives us the answer. Our old friend the cone shows up again, this time defining the system's total capacity for chaos. It can handle its own internal randomness, plus the randomness it pulls in from the outside world, but only as long as the grand total doesn't overflow the cone's limit. The cone is like a chaos container, preventing a total meltdown. All right, the plot thickens. We have a living, evolving system that plays with chaos but stays within its limits. So, who's in charge? Who's calling the shots? Let's unmask the governor at the heart of this machine. And that brings us to NETAᵜ. According to Canon 16, NETAᵜ is an AI agent, and its entire job is to make the optimal choice. It's constantly trying to maximize three things: being consistent with the past, making sure its data is valid, and of course, keeping the whole system safe. You can think of NETAᵜ as the brain of the operation. So you can almost imagine its little checklist, right? Every single time it wants to do something, it's asking itself, okay, does this move fit with everything we've done before? Is the data structure solid? And most importantly, is this safe? Only after it's weighed all of that does it pull the trigger on what it thinks is the best possible move.
But here's the thing, NETAႜ isn't just some abstract pie-in-the-sky thinker. It's also a hardcore accountant. Canon 23 makes it clear that NETAႜ has to follow a very strict budget. Every single action costs something, in computing power, in bandwidth, in memory, and if the cost is too high, the action gets rejected. It doesn't matter how great the idea is, NETAႜ is an economist.
And then we hit Canon 19, and honestly, this is the bombshell. This is the big one. The document just comes right out and names a large language model, an LLM, called Jetstreamin. And it says this LLM is being actively managed by NETAႜ. It has to balance its performance against real-world costs like budget and speed, all while staying inside that canonical constraint, or cone. So the brain, NETAႜ, is running a powerful language model.
Okay, deep breath. We've got all the pieces on the board now. We've got the unbreakable history, the guiding cone, the chaotic evolution, the AI brain, and the language model. Let's step back and see what this puzzle looks like when it's all put together.
So just think about what we found. We have a system with a perfect cryptographic memory. It lives inside a mathematical shape that keeps it stable and on track. It's constantly evolving, and it even invites chaos from the real world to keep itself sharp. And the whole thing is run by a rational, safety-obsessed, budget-conscious AI that's managing a powerful language model. So when you see all these pieces together, you realize something crucial. This isn't just a list of rules. It's not just code. It reads like a blueprint, almost. A constitution for a digital life form. It's got memory, it has a physical boundary, a way to evolve, and a mind making rational economic choices to keep itself safe and sound. And that leaves us with one huge, mind-bending question. Is that what this is? Is the Jetstreamin Canon the mathematical blueprint for a new kind of autonomous, self-sufficient digital intelligence? A system designed from the ground up to learn, adapt, and survive all on its own? The document doesn't give us the answer. It just gives us the math and leaves the rest for us to figure out.